Hello, welcome to the first grade Unit 5 PLC Deep Dive. I'm Nikki Mackey, your host for today. This is our agenda for the day. You will make your own personal copy of the note catcher, and you can jot things down to be able to refer back to as you prepare for weekly lessons in Unit 5. Let's get set up with our resources. You will need to open Launchpad and click on Canvas. Next, click on Math Rocks in first grade. Unit 5 is where you will find our resources for today. Open up the curriculum guide. Pause the video here if you're still working on opening up your resources for Unit 5. Let's familiarize ourselves with the overarching story of the unit. We will begin with diving into a couple of standards. Let's open the unpacking document that comes from NC DPI. The link can be found on slide 4 of your curriculum guide. There is space on your note catcher for you to capture your thoughts and answer questions. You will notice in your note catcher 3 standards. When we are unpacking these standards, we are going to answer these 3 questions. What are the verbs to identify the skills and strategies needed? What are the number parameters mentioned in the standard? What vocabulary is required for student mastery? In the NC-DPI unpacking document, you can find NC1 MBT4 on pages 25 and 26, NC1 MBT5 on pages 27 and 28, and NC1 MBT6 on pages 29 through 30. You'll spend about 15 minutes unpacking these standards. Pause the video here while you get to work. Welcome back. Let's highlight some things you noticed in NC1 MBT4. Hopefully some verbs you identified were using models, drawings, and reasoning, explaining, and adding. There are big number parameters for this standard. We are adding a 2-digit number to a single-digit number and a 2-digit number to a multiple of 10. Notice the tools and drawings that may be used to explain as students solve. They may also use towers of tens and single connecting cubes. Students will use a lot of place value vocabulary like tens and ones when describing numbers. It's still a good idea to use connecting cubes instead of the traditional base 10 block so students can compose towers of 10 when adding single digits or 1 digit to a 2-digit number. Our curriculum offers base 10 drawings as a representation, and those look like long rectangles to represent the 10 and a small square to represent ones. Students become familiar with the idea of the commutative property in this standard. They also do a lot of decomposing numbers. Sometimes decomposing numbers can get students to the next 10. For example, if I was adding 48 plus 5, I could decompose the 5 and think 48 plus 2 equals 50, and 50 plus 3 equals 53. I could show that new 10 by adding 2 cubes to 8 cubes to create a tower of 10. We unpacked NBT 5 in Unit 4, but it's worth a chat in this unit too. The goal of the standard is for students to be able to explain 10 more and 10 less mentally by the end of the year. Students can practice with support so they have a point of reference when they explain mentally. They may visualize a hundreds chart, 10 frames, cubes and towers of 10, or they might think about base 10 drawings. Students are building on their NC1 NBT2 knowledge when thinking about 2-digit numbers and adding 10 more or taking 10 away. Finally, you unpacked NC1 NBT6. Some verbs you may have noticed are subtract, explain, and use when it comes to strategies. Some parameters in this standard are multiples of 10 from a multiple of 10 in the range of 10 through 90, Note the expectation for what a first grader is supposed to compute when it comes to this standard. You will hear similar vocabulary in all three of these standards. Students can be offered 10 frames, cubes and towers of 10, and singles, or hundreds charts to support them in this work. I would like to invite you to return to the Unit 5 curriculum guide. On slides 10 through 13, read through the overview and the summary of the sections. Feel free to jot down any notes in your note catcher section you see here after you read or while you're reading. Think about where the invitation, deep study, and consolidation show up throughout the unit. Pause here and spend about 5 minutes on this task. What you may have noticed in this unit are students are adding within 100 using place value understanding and properties of operations. In Section A, they add 2-digit numbers with a single-digit number or a 2-digit number to a multiple of 10, and it's not necessary for them to compose a new 10 in Section A. In Section B, they add 2-digit numbers with a 1-digit number or a multiple of 10 where it's necessary to compose a new 10. In Section C, they continue to add 2-digit number and a 1-digit number and multiple of 10, but they also subtract a multiple of 10 from a multiple of 10. They interpret and write equations using drawings and other tools for sense making. The unit overview is included to familiarize teachers with the overarching story of the unit. Feel free to refer back to the unit overview and section summaries to know what students are expected to demonstrate. Next, we're going to sort tasks across the sections. You can reference the slides 10 through 13 in your curriculum guide as you think through where these tasks may be found in each section. Also notice what is different and similar about each one. The bit.ly is on the screen and in your note catcher for you to access the tasks. Pause here and take about 10 minutes to sort. Take a moment to check your work. What you may have noticed in this unit is students add within 100 using place value understanding and properties of operations. Let's see how the standards and learning goals make up the math story in Unit 5. It is important for us to do the math ourselves in order to develop a deeper understanding of why certain representations and procedures are used throughout the story of the unit. As adults, we may not have used these representations or procedures to teach or learn the concept in this unit. Therefore, it is essential that we have time to make sense of the mathematics in the context of the representations and procedures in the curriculum. We also need to anticipate how our students will make sense of the mathematics in the unit. As you are solving these tasks, ask yourself, why is it important to have towers of 10 connecting cubes accessible for students throughout the unit? Why is it important for students to represent their thinking? Pause here for about 8 to 10 minutes to work out these tasks from each section. Think about the representations and strategies students will use. In Section A, students add 2-digit number with a 1-digit or a 2-digit number without composing a 10. And that 2-digit number is a multiple of 10 that they're adding. They build on the work of prior units in which they add 1-digit numbers and teen numbers without composing a 10, and then added multiples of 10 to 2-digit numbers. Here, students see that when they add 2-digit numbers, they can add like units. They could add 10s and 10s, or maybe they're adding 1s and 1s and then the 10s. When adding, students may use connecting cubes or drawings or hundreds charts to show the grouping of 10s and 1s to compose a new unit of 10. They are encouraged to explain, connect, and compare their methods for finding the value of sums. Monitor the language students use to describe their methods or strategies and emphasize vocabulary related to place value. Give students opportunities to revise their explanations and add their representations for clarity and precision. Students will then write equations to represent their thinking. Section B, students think about making a new 10 when adding a 2-digit number to a 1-digit number. To deepen their understanding of place value and properties of operations, give students opportunities to compare and contrast different methods, as well as to connect their methods to representations that make sense to them. In Section C, we allow students to apply what they learned about adding 1-digit and 2-digit numbers and 2-digit numbers and multiples of 10, with and without composing a 10. They apply the associative and commutative properties as they count on, add 10s and 10s, or add 1s and 1s. Students see that no matter which order they use to combine the parts of the addends, the sums remain the same. Additionally, in Section C, students practice subtracting a multiple of 10 from a multiple 10 from 10 through 90. This is the story of Unit 5. Next, we want to think about backwards planning. End-of-unit assessments can be used to plan in ways to support students throughout the unit as they work to make sense of the unit learning goals and standards. On slide 8 of the curriculum guide, open the student answer sheet linked on the page. As you work through the tasks, think about the strategies students would use and identify where each task represents one or more section-level learning goals. Also identify the standards in your note catcher. Pause the video here and take about 8 to 10 minutes to work on the tasks. The next resource that is helpful is the assessment rubric. Open that link on slide 8. Read over the assessment rubric and check your answers from the tasks. Did you identify the correct standards and sections where these tasks could show up? The unit assessment is a good place to start with backwards planning, but it is important to remember that's just one piece of evidence to consider when identifying a rating for standards. It's not the only thing we consider. The Unit 5 rating guide, linked here in the center of the slide, helps us consider all checklists, observed behaviors in class, practice problems, and cooldowns throughout the unit. You will also find exemplary mastery tasks to help you determine if a student is demonstrating mastery or exemplary mastery of the standard. Not all students will need to be offered these exemplary mastery tasks, but they are available if students are consistently displaying mastery. The rating guide is in Mastery Connect to help you keep track of standard ratings for progress reports and report cards. Let's take a look at Lesson 3 and how Activity 1 sets students up to be successful. Students were going to add 2-digit numbers using a method of their choice and write equations to match their thinking. Students interpret and compare different methods for finding the value of the same sums. Students also practice explaining their own methods and listening to the methods or strategies of their peers. Students have opportunities to revise how they explain their own and others' methods and consider how representations of their own thinking, for example, drawings or equations, and how it can help them explain and interpret their work. Let's take a look. Activity 1, Lynn and Han add. The purpose of this activity is for students to make sense of the first step of addition methods and then finish finding the sum. They use representations to show their thinking. In the synthesis, students have opportunities to share how they represented a method with equations and connecting the representations using their understanding of place value. This is a partner activity. Lynn and Han are both finding the value of 32 plus 50. What should they do next to find the value? Write equations to represent your thinking. Pause the video here while you look at Lynn and Han's work and solve for Activity 1. So some sample responses that students may say is that Lynn needs to add 1s and 10s. So they might write 80 plus 2 equals 82 because Lynn has already added the 10s together. Student might say that Han needs to add or count on 2 more from 80 on the 100 chart. And they might show that by jumping 2 squares to the right. Students may write the same equation for Han, 80 plus 2 equals 82. Once you've monitored students to see what they have represented in their work, identify students to share their equations and explain their thinking. Ask them how these equations are the same and how they're different, or how their methods of getting maybe to the same equation is the same or different. Think about some representations or some responses that students may use in your classroom. Let's check out some key points and next steps. Today, we unpacked NC1 NBT4, NBT5, and NBT6. We uncovered the mathematical story of Unit 5. We aligned lesson goals and standards and have the end in mind. We also discussed representations we should see students creating to meet the goal of the lessons and standards. In your next PLCs, review NC1, OA9, OA6, and NBT2 since they support the work in Unit 5. Read through the curriculum guide, the lesson notes, and small group resources. Prep any copies and centers you will need. Consider incorporating these activities into your PLCs. Lesson 2, Activity 1. Lesson 6, Activity 2. Lesson 11, Activity 1, and Activity 2. Feel free to send me an email with any questions or wonderings that may come up. I'd love to see pictures of your students working or work samples. Please email me, send them my way. See you next time.